Welcome to lesson 4 of our introduction to the Java programming language. In this lesson, I will show you how to create and use your own custom objects and classes. And by doing so, we would cover methods and attributes of a class. You will learn how to accept user inputs in your application. You will know how to manipulate data with what we call operators. And I will conclude this lesson with a UML diagram that illustrates the contents of a class. Java is an object-oriented programming language. What it means is that it makes use of the concept of real-world objects in application development. To understand objects, you must understand what classes are. So, a class in Java is a blueprint or template from which objects are created, while an object is an instance of that class. You can think of a class like a prefilled form, and the object will be the form with all the missing details. Now, that means that a class would contain predefined features and behaviors of the objects to be created. Then the object would contain the actual data and behaviors that was predefined in the class. To create a class in Java, we usually create a file, and the name of the file would be the name of the class. So if we create a file BankAccount, that means inside a class we have a declaration class BankAccount with curly braces. And to create or instantiate an object, we use the new keyword. So to create an object of the BankAccount class, we would say new BankAccount. Talking about objects, we can relate objects to real-life entities. So let's take, for instance, a dog. Now a dog will have different attributes and behaviors. So the attributes of the dog could be like the dog's name, which would be string, the dog's color, which can be expressed as string as well, the dog's age, as well as other behaviors that the dog can exhibit. So these attributes in Java can also be called members of the class, and the behaviors are called methods. Now, a class would not have the value for the age, the string, for the name or color. It is at the point of creating an instance of the class that all these attributes are given values. And we can think of bank accounts also as an object. Now your bank account will have information such as your account name, your account balance, and as well as other information like if the account is active or not. And the behaviors of the account will be things that you can do in your account. So for instance, you can deposit money, you can withdraw or get balance. You would notice that the behaviors or methods of a class can have data types. So for instance, we have the double get balance. Remembering that a method performs a specific action. So the get balance method we have here performs the action of fetching the user's current balance and returning it to the user. Now, because it returns a value to the user, which is the balance, that value is in double. So that's the reason why we have double get balance, because the balance is a double and it returns the balance to the user. And for the withdraw, you can think of it like whenever a user withdraws some money, we have a message that is shown to the user, and messages in Java are represented as strings. For situations where the methods do not return any value, we can mark it as void, and that's why we have the void deposit. So the void is a keyword that shows that a method does not have to return any value to the user. We can go ahead and create a class bank account. That would be a blueprint or template for creating new bank accounts in our application. So I would go ahead. Let me first of all delete this class. We won't be using this class in our application, and since it no longer exists, we have an error here, so I'll just remove this. And to create our bank account, remembering we are in the package com.jhim, we'll go to com.jhim, we'll click on new, and then we'll create our bank account class. So to create our bank account class, just type in bank account, and that creates a bank account class for us. Remembering that classes should start with an uppercase letter. That's why we have capital B here. And so this would be our template. And we said that classes will have attributes, or we call them, you can see, members of field variables. And we would also have methods here that define the behavior of this class. Now we have established that the bank account will have certain information, right? Like your first name, your last name, your age, and the likes. Now, classes are meant to be blueprints, and every variable that is defined in the class shouldn't have a value that is assigned to them until an instance of the class is created. Imagine for our first name, we need to type in string first name. Usually we would assign this to a value, like say John. But because the class is supposed to act like an empty form, and by the time we create an object of this class, it's when we are supposed to assign a value. So we would remove this assignment of this variable to John, and we just have the definition. So we simply just define a variable first name as string. And similarly, we can have last name. And let's say we also want to store user's phone number. Now, the reason why I'm using string as a phone number instead of int is because a phone number can start with 0. And if you use int for a phone number, by the time you store the value, if the phone number starts with a 0, it's going to omit that 0. So an integer would simply store the value, the actual value, while a string will leave value of that variable exactly the way it is. So I can just show you that by creating two variables. Let's say we have let's call this phone number, and we have, let's say, 012. So let's assume this is our phone number, and we have another variable. Let's have 012 here. Let's say phone number 2. Now you see it's even giving us a warning. That means that by the time we print out this number, it's not going to give us 012 the way it is here. You should be careful with data that seem to look like numbers. So things like a user's phone number or account number that has the tendency of starting with a 0. The value should be, that kind of data should be stored as string. So I'll just do SOT, shortcut for system out print line, and then I'll print out, let me just say I print phone number here and phone number 2 here. I'll just run it, and now you can see that the phone number we stored as string that starts with 012, it gives us 012 here, but the phone number that has 012 as saved as integer gives us something different. So anytime you have a number data that you want to save that starts with a 0, you should save it as string and not integer. Now that we have that out of the way, let's just clean up this, and so we can focus on creating instances of the class that we just created. We can go ahead and define other members of this bank account class. When a user creates a new account, he would have an initial deposit in creating the account. And this initial deposit would be in number. could have decimal places. I would say initial deposit. Just define it without a value. We can create an instance of this class. For us to create an instance of this class, from our last lesson, you remember we type in the class name. We type in the variable name you want to use and assign it to new class name, and with parentheses. Let's go ahead and create an instance of the class bank account. We'll type in bank account and let's call this variable name account, and that would be assigned to new. So the new is creating an instance of bank account, and that means we have created a new bank account record. And let's go ahead and check what we have for the variables of this account. Now that we have created an object, this is an object, and this variable would be a reference to this object that is created. And we can say system out print line. Let's just try and print the first name to see what we get. Now it gives us null, and let's go ahead and print the initial deposit. So we have null for our first name and 0.0 for our initial deposit. Why is this so? It is so because these attributes do not have values yet, and so they have been assigned a default value. Whenever you define a variable in a class without yet assigning it a value, it's given a default value. Now, non-primitive types like the string is null, and the default value for numbers such as double is 0.0. And we can also go ahead and check the default value for age, and you will see the default value for age is 0. And the default value for a boolean, we say boolean is active. The default value for a boolean will be false. So if we go ahead, and you see it says false because we have not yet assigned values to these variables. To do so, we can simply type in account, which would be the variable that makes references to the instance of the bank accounts, and we'll put a dot. Now the dot will give us a list of all the attributes and methods that we have defined in class bank accounts. In this case, we want to assign the first name to a value, so we can say equals. Now because it's a string, we'll put John between a pair of quotes. If you put a number here 3, tell us something is wrong. So because they say the required type is string, and the required type is string because it was defined as string here, that means that when we are assigning it, we assign it a value of string. Now by the time we run this our application, you would now see that John is printed here. And we can do the same for our initial deposits, age, and the likes. And I'll just quickly do for initial deposits, and because this requires a double, I can put let's say 8.0 and run this, and you see it gives an initial value. But when a user creates an account, we of course will not know the details you want to supply, and the user would be the one to enter such details. To enable the user enter his details, which we can use to assign values to these attributes, we use the scanner class. So let's go ahead and create an object of the scanner class. So the scanner class allows us to input information to the application. and this way we can use it to we can use the information supplied to assign values to the attributes. To create an instance of the class scanner, we type in scanner, and let's just call the name of the variable scanner equals new scanner. The scanner class requires something for us to supply it with, and that is the system.in. So we are going to talk about this in a subsequent lesson. So sometimes when you create an instance of a class, it might require certain fields. In this case, it requires that the scanner has the system input object. So this system.in enables the scanner to register a user's input. And you'll notice when we created the scanner class, we have something import Java util scanner. Now the import word you see here is a key or reserved word, just where we have package, import, public, class, and the rest of them. And what this import does is that it fetches information from a different package. Now you remember that a package contains a list of different classes. So our package com.jim, we have our bank accounts and main. And this java.util is a package. That means that we have a package somewhere else we did not create. And this package is supplying us with a scanner class. So this package and the class scanner has been created for us, and we simply import this scanner class into our code to make our work easier. So there are many of such packages that have been created for us in Java. We can see some of them in the external libraries. You will see we have some packages here. So if you scroll through, you will see we have something like jdk.net and the rest of them. So these are package java.util package, and under the java.util package is where we have our scanner class here. So we have our scanner class that have been defined for us here. So these come with the JDK, the Java development kit. So that means the Java development kit has written some classes for us. Back to our code, we have created an object of the scanner class. This has been imported for us. If we comment out this, we have an error. So we must import this scanner class to be able to use it, because it's in a different package from our application. We did not need to import the bank account because classes that are within the same package don't need to be imported. We have bank account and main here, so they see each other and no need to have an import here. So we've created an object of the scanner class, and in order to request for user input, we simply type scanner dot next line. Now what the next line method does, the next line method would pause the program in order to receive input from a user. So let's go ahead and run this application to see. You see now that we have a blinking cursor. Now the blinking cursor is expecting an input from the user. So if we type in John, until we type in John and hit the return key on our keyboard, now you would see that the rest of the application runs. But we don't just want to leave like a blank cursor that blinks. We want to tell the user what's going on in our application. And to do so, we can print out a message that says, "Can I know your name?" And I want this to be print statement so that the blinking cursor will remain on this line. So if we go ahead and run this, now you would see it says, "Can I know your name?" which is this, and then it goes to the next line, line 12, which is scanner.next line, that waits for the user's input. I type in John, and then you can see that the rest of the application runs. But we don't just want to ask for the user's input. We want to receive the user's input and store it in the variable first name. So let's modify this by saying, what is your first name? And to be able to get the first name and assign it to this variable first name, we simply copy and just copy this. And so what it means is that whatever value or whatever text that is typed in here will be assigned to first name. And to see the result of what we did, we can say, okay, so your first name is, let me make this print, and then I have account dot first name. So if I run this application and it asks me what's my first name, so let's say my first name is Jane, and I hit enter, you would then see that we have, okay, so your first name is Jane. Similarly, we can request for the user to type in the amount he wants to use as his initial deposit. And that means that we can ask a question before we print out the first name. So we would say, what would be your initial deposits? And we are also going to use a scanner.next line as the value for the initial deposit, but we have a problem. Now the problem is that the scanner.next line performs some actions and return a string. Now you remember in our introduction to this lesson, we said that some methods actually return values. So that's what the next line method does. And we can resolve this error by typecasting. But how do we typecast from a non-primitive type like a string to double? Because initial deposit is defined as a double, but the next line is providing us a string. So in the previous lesson, I showed you how to convert one primitive type to the other. So if you have like an int and you want to convert it to long, you would typecast. But in this case, we are having a string which is a non-primitive type, and we are converting it to a primitive type. So to do so, we have what we call wrapper classes in Java. Wrapper classes are like the non-primitive versions of the primitive data types that we have in Java. So for instance, we have a double, class double. We have class integer. We also have the float class as well. And to convert a string to a double, we use our wrapper class double and call a method pass double. Now you will see that this resolves the problem of converting a string to double. If you put your cursor over the pass double, you would see it returns a new double initialized to the value represented by the specified string. So this is a class double, and the pass double helps us to convert or typecast a string to double. And similarly, we have float.pass float. We have integer.pass8 and the rest of them like that. So we can say integer.pass8, and this will be expecting a string. So now that we have that out of the way, we can as well print out a message for the user that says you have deposited, and what we'll print out next would be the initial deposit. So let's just rerun our application, and it asks me what's my first name. Let's say Matthew, And what will be your initial deposit? So I want to deposit 65,000. And this tells me, okay, your first name is Matthew. You have deposited 65,000. Well, I hope you didn't find that confusing, but if you do, I would encourage you to rewatch the video, or certain parts of the video that are not so clear to you at first, because it is typical of software developers to go over materials for learning new frameworks or technologies. And I would also encourage you to code along with me. That way you can help build your muscle memory. And let's see how we can clean up this code, because it is not proper to create a bank account and then start asking for the user's bank details. So we want to structure our code in such a way that we would request for the user's details and use those details to create the new bank account. So let's go ahead and see how to do that. We've cleaned up the code and you see that it makes more sense now. So we'll start by a welcome message to welcome the user to our application. And then this will just print a blank line so that it will give a space between this message and the next one. And then we also print 2 blank lines for readability. And we also tell the user that we want to get his details in order to create the bank account. So we ask, what's your first name? And once we have the first name supplied, we save it in a variable called first name. Now this variable is not the same variable as the bank account name. It's a different one. And we go ahead and ask for the last name and all the other information. Now, after collecting all the vital information that we need in creating our bank account, we now create the new bank account with the first name. This account of first name is this one that is here, and the first name here is the one we declared at the top. So we do the same for all the other variables, and you can see that we now display a message for the user that we have successfully created a bank account. So let me go ahead and run it with Ctrl R. And now our application starts running and it asks me, what's my first name? Okay, I'll say my name is John. Last name is Doe. My phone number is just 01. How much do I want to deposit? And now you can see that it says you have successfully created an account with the following details. Your name is John Doe, your phone number is this, and initial deposit is this, which is what we have written here. So let me zoom in so you can see the contents of this file. Yeah, so we have this here. We've discussed about how to create an instance of a class, which is an object, and as well as how to assign values to the attributes of the class. And we've not created our custom method. So remember that a method performs actions, and all these code that we have written can be put inside a method. So why don't we create a method in the bank account that is responsible for creating our new bank account? To do this, we have, let's say, create account, and here, because this would not be returning any value to us, we'll just mark it as void. If it was supposed to return a value to us, we will return like maybe the data type of the value, but we're not doing that here. It's not going to return any value to us. So what I would do is I would copy the contents of this and would paste it here. And so what it means is that we can use this method in creating our account. So how do we do that here? Now, how do we access this method? Because, you know, in order for us to create a bank account or to be able to access the attributes of a class, we needed to create an instance of the class. That is by doing this here. But we said that we don't want to create the bank account before asking the user for the vital information that is needed in the account. And we can avoid creating an account and calling this method if we mark this as static. Now, the static keyword is something that helps us to access this method without creating an object of this bank account. So let's see how it works. So for us to do that, we can say bank account, and if you put a dot, you would see we now have access to the create account. If we did not mark this as static, if we remove static, you would see we have an error message here. So it says non-static methods cannot be referenced. So we mark this as static. Now we can go ahead and run it to see what we get. And you see that the code runs exactly the way it was initially. If we say Jane, and we type do, and number initial deposit. Now you see that our code runs exactly the way it was before. What does a method do? So a method, and in some programming languages, methods are called functions. So a method simply allows us to run a block of code. Now you would see we have the method, we have the name of the method, we have the return type. That means if the method is returning the value. And by return type, that means that we can assign the value to a variable. But we're not doing that here, so we mark it as void because this method does not return any value. And we have curly braces that indicates the beginning of the method and the ending of the method. And by the time we mark this as static, the static keyword allows us to be able to access this method without creating an instance of this bank account. Imagine if we wanted to BankAccount dot, you would see that we are not getting any methods or members of the class except the create account. But if we change this to static, and as well change the attributes to static, you would see that now by the time we put a dot, you will see we can access the first name. That's how we are able to access a method without creating an instance of the class. So I've shown you how to create a method that does not return any value. We can as well have a method that returns something. And you remember from our introduction, we said that we could have a method that after the user has created an account, we might want to get the deposit or the balance in the account. And this method, we call it, say, get balance. And it will give us an error because we need to specify the return type. In this case, we want to return the balance in the account. And the balance would be in double. That means that we want to have a field called balance. And we believe that since it's the first time the user is depositing money to the account, the initial deposit will also be the balance. So we can say initial deposit equals initial deposit. And the get balance will simply return the balance. And to do that, we type in the keyword return and then the variable that we want to return. So to get balance, we just simply return the balance. So we have seen how to ask for the user's details and use that in creating an account. There's something else I would like to show you. which is how to manipulate these inputs. So let's just clear this for now and go back to the way we tried to create an object of the bank account. So let's just say bank account, new bank account, and we create the scanner class. Okay, so what we have here is we want to assume that the account has been created and we want to ask the user for deposits. So let's say this is a scenario whereby the user wants to deposit some money to the account. And to do so, that means we need to have a method to deposit money. So let's go to our bank account and we create a method to deposit money. Let's call this method void and we'll say make deposits. Now I would like to have this scanner class inside the method. So what this method will do is this method will ask the user to enter the amount he wants to deposit here. And by the time the user enters the deposit, what it does is that it's going to manipulate the balance of the user here. Talking about manipulating data in your application, it's the perfect time to introduce you to operators in Java. And operators are special symbols used to perform operations or one or more operands. They are useful in manipulating variables and data and are categorized based on the functionality they provide. We have the following types of operators in Java: the logical, arithmetic, shift, relational, bitwise, ternary, assignment, and unary operators. In the context of this tutorial, I would explain the arithmetic operators as well as the assignment operators. The assignment operator is the equal sign we use in assigning a value to a variable, and the arithmetic operators are operators that helps us to perform mathematical operations in our application. So if we want to add two numbers together, we use the plus symbol between the two numbers. Now please take note that the numbers could be whole numbers or numbers with decimals. That means the numbers could be of a type int, long, float, or double. And by summing these two numbers together, we can then assign it to a new variable. So let's take, for example, we have a number int a equals 5. We have int b equals 3. To add these two numbers together, we can assign it to a new variable sum and say a plus b. And the same goes for subtraction as well. So to subtract the two numbers together, we can have int, let's just call them the variable minus, and say a minus b. Furthermore, we have the asterisk symbol used for multiplying numbers, as well as the backward slash for doing divisions. That means that if we have, let's say, int x equals 8, int y equals 3, then we can multiply the two numbers and assign to a variable multiply. You can say 8 times 3, where this symbol is representing the multiplication of the two operands x and y. So the x would return the value for 8, so it will replace this x with 8, and this y will be replaced with 3. So we have 8 times 3. Similarly, we can also do power division, and if we have int division equals, we say x divided by y, and what this will do is it will give us the whole number value of 8 divided by 3. So 8 divided by 3 would be 2 remainder 2, or let's change this to 10. So if we have 10 divided by 3, this symbol is going to return the quotient value. So that means we are going to get the value of 3 here because we are dealing with integers. And if we were dealing with, let's say, numbers like float or double, then the result will be returned in double, and that means we're going to have like 3 points something. But dividing integers does not mean that the remainder will be lost. We can get the remainder by using a symbol modulus. So what this modulus will do is it will return the remainder from this division. That means that if we say int modulus equals x modulus y, we are going to get the remainder of 10 divided by 3. So 10 divided by 3 would be 3 remainder 1. And we can just go ahead and do a print statement for everything that we have done here, and modulus. And we can call this method we can say account dot make deposits and run this. Yeah, and now you would see that we have the sum 5 plus 3, which is 8, 5 minus 3, which is 2. We have x 10 times 3, which is 30, and we have 10 divided by 3, which is 3, and then the remainder is 1. But if we were to put this as a double, so let's say these numbers are double, and we will run this our application. Now you will see that because it is double, our division does not just return the whole number, but it returns the exact value. Similarly, if we change this to float, you would see that we have 3.3.3 with less precision. So as we have said in the previous lesson, that we have float and double that could represent decimals, but the precision of double is higher than that of float. So for float, you can have up to 7 decimal places, and for double, we can have up to 15 decimal places. Back to our banking app, we can then apply what we have learned to make deposits to the account. That means that when a user deposits money, we can add that amount to the previous balance saved in the account with the plus symbol. Let's say when a user specifies an amount, so in this case, we can use double deposit amount would be, we use our scanner dot next line, and we'll wrap this with double dot pass double. So this would be the deposit amount. Now what we can now do is we have our balance. So our balance will now be assigned to the previous balance plus the deposit amount that has been specified. So we can go ahead to do our system out print line, and we would say your new account balance after deposit is, let's make this print rather, and then we have our balance here. But I'll do something. I would also want to print the balance before deposits. So that means we can say your balance before deposits is, and then I can have let's say balance here, and I would just want a print line to give a space between these print statements. So we have our accounts dot make deposit. So if we go ahead and run this, so it says I should enter my deposits. So I would say 76,000. And now you would see it says your new account balance is 76,000, but my account before deposits is 0.0. So that's one way to manipulate data in your application. And another way to manipulate data in our application, let's create a method which will return a string, and then this method would be withdraw. So in this case, what this method will do is it will prompt the user to enter the amount he wants to withdraw. And okay, we'd say your balance before withdrawal is this, and then we would prompt the user to how much will you withdraw. So now we can have our withdrawal amount would be equal to, we have our scanner dot next line. We'll wrap this with double dot pass double. Now what it means is that because the user is withdrawing some amount, we need to minus this amount from the previous balance. So we can go ahead and do balance. Our new balance will be equal to our previous balance minus the withdrawal amount. So we can then say system out print line. Okay, I'll just copy this instead. I'll just copy this instead and paste it here. But we have an error message here, and that's because whenever you specify a method to return a particular data type, we must end that method with a return statement. By doing return and the data that kind of represents the data type that has been specified for the method. So in this case, we have specified a string, so we must return a string here. If we put double here, you would see it says required type is double and string was provided. That means if we put something like 4.0, you would see the error is gone. And if we mark this as void, that means we are not going to return anything. And this says that it does not return any value. So you can either do this or not put any return statement at all. But what we want to do is we want to return a string, right? And let's say a string that says withdrawal successful. We can as well create a variable instead and then copy this message and assign it to that variable so that we can then return the message. And I would just want to leave a blank line here. Now, in our main class, we can then allow the user to withdraw some money. So we'd say withdraw. But you remember that the withdraw returns a string, right? And we want to make use of that string. So what we can then do is we can then assign the return value to a variable. So we can say withdraw message, and we can now print out a new statement that says that prints out the value for the withdraw message. So let's go ahead and run this. And it first asks me enter your deposit. So I'll just say 600. Now it says your new account balance is this, and your balance before withdrawal is also this. So if I withdraw 50,000, then I will have your new account balance after deposit is 550,000. Now that 550,000 is coming from these print statements, while the withdrawal successful, which we have here, is coming from these statements. So this account.withdraw is going to run the block of code that we have here, and after that is going to return a message withdrawal successful, which we assign to this variable, and then print out the message for the user. So there's something else I would like to show you. So imagine if the user is trying to withdraw more than what he has in his account, and you know in real life that is not possible. But currently, the way we have created our application, it's possible for a user to do that. And so let's just say we make a deposit of 20,000 and want to withdraw 30,000. Now you will see that this works, right? It says your new account balance is minus 10,000. But in real life, we do not want the user to withdraw an amount that is more than his balance. And there are other things that can go wrong with our application as well. So for instance, we do not want to expose the field variables that are declared in a class to other classes. So for instance, if I say account, I can access the first name and I can access other variables as well, right? And in the next lesson, we are going to see how to resolve these issues, and we'll modify our application to make it more realistic. We've now reached the last chapter in our lesson 4, which is the UML diagram. UML stands for Unified Model Language, and is a general purpose visual model language that's intended to provide a standard way to visualize a system design. We can visualize a class by UML diagrams, just like what we have here. So in this case, we are representing our bank account class with a UML diagram. And at the top here, we have the class name. And the next section contains all the field variables, like our first name, last name, the balance, age, and the likes. And the third section of our UML diagram will show us all the methods that we have. Now you will notice we have a minus here and a plus here. These are called access modifiers, and we have different types of access modifiers in Java. We have the public, the private, the protected, and the default. Now we didn't use that in this case study so as to make it less complex, but in our next lesson, I will show you how to change the access of the field variables in Java. And this is to add some layer of security to our application, as I mentioned earlier. And we would discuss how to change the access of field variables and methods.